In this video, we will look at how to graph linear systems. So before we do that, we want to refresh on what a linear equation is. And it's just the equation of a line. Now, when you have a linear system, it is a set of two or more linear equations that are being considered at the same time. And the solution to a linear system is the point of intersection. We will be looking at scenarios where we have two lines and we're trying to find that point of intersection. And this can happen in three different ways. First of all, you could have one line here, another here, and here we are. There's the point of intersection. We have one solution. But what about if we have two lines, but they're parallel? If they're parallel, they will never intersect, and as a result, there are zero solutions. And finally, you can have one line, and the other is just directly on top. So if our two lines are the exact same, that means we actually have an infinite number of solutions. But in most scenarios, we will be right over here where we have one solution. There are actually three different ways to solve a linear system: by graphing, which is what we're going to be looking at today, but also two algebraic methods called substitution and elimination. But let's go ahead and start with graphing. So first of all, you want to make sure that both of your equations are in y equals mx plus b form. That way you can actually graph the line using the y-intercept and using the slope. Once you graph your two lines, you're just reading your graph and identifying that point of intersection. So let's start with our first example. Here is our system. We have two equations, y equals 2x plus 6 and y equals negative 1 over 2x plus 1. In this first line, our y-intercept is 6, so I'm going to go ahead and plot that. And my slope is 2, but I want to write it as a fraction, so 2 over 1. That way I see my rise and my run. So my rise is 2, and it's positive, so that means I'm going to go up 2, and my run is positive 1, so I'm going to go to the right 1. So I'm just going to do that. Up 2 to the right 1. Up 2 to the right 1. And for the first line that you graph, I want you to extend it through your entire grid. So you're going to apply that slope quite a few times. Now you will notice that I've run out of space here, but going back to my y-intercept, instead of going up 2, I'm going to go down 2. And instead of going right 1, I'm going to go left 1. And that way I'll continue that same pattern. Down 2, left 1. And there we are. I want really good accuracy for the first line. Arrows at the ends, and because we will have two lines on the same grid, we are going to label our line. Now let's go to the next one. Our next line has a y-intercept of 1. So I'll plot that point. And my slope is negative 1 over 2. Because my rise is negative, that means I'm going to go down 1. My run is positive though, so I'll go right 2. So down 1, right 2. Now when I apply that slope, I'm actually getting further from my line. So I'm going to switch both directions. Instead of down, I'm going to go up. Instead of right, I'm going to go left. And then I actually hit the other line, which is perfect because I am looking for the place where they intersect. Now I am going to connect my dots and put arrows, label my line, and now let's read off that point of intersection, which is right here, The coordinate is -2, 2. Always put the x value first. And now our therefore statement. Therefore, POI, point of intersection, is -2, 2. All right, let's try another one. So my first line has a y-intercept of -4. So make sure you're in the negative section of the y-axis. And our slope, m, is 2/3. They're both positive, so I'm going to go up 2, right 3. Up 2, right 3. And because I want to do the entire grid, I'm also going to go back to my y-intercept and now go, instead of up, down, instead of right, left. So down 2, left 3. Now I'll connect my dots. You should do this with a ruler. Label my line. And now let's go to the next one. So here we have a y-intercept of +4. So I'll go to the positive y-axis. And the slope is -2, which I'm going to write as -2/1. So that means I'm going to go down 2 because of the negative rise to the right 1. Now going in this direction looks good. It looks like I'm going to hit my line. So again, down 2, right 1, down 2, right 1. And I hit the other line, so I'll stop applying that rise and run. I'll connect my line, write the equation, and now we can read off this point of intersection right here, and that is your answer. So therefore, POI, point of intersection, is the x value is 3, the y value is -2, so there we are. Make sure you're doing x comma y. All right, let's go to C. And I'm going to have you try this one on your own, but I'm going to make a few changes here. We should have 1/4x subtract 5. So why don't you pause the video here, graph both lines using the y-intercept and the slope, and identify that point of intersection before you come back and check your work. So the first line has a y-intercept of 4 and a slope of -2/1. So here's my y-intercept of 4, and I'm going to go down 2, right 1, down 2, right 1, and I'm going to keep doing this to fill the entire grid, and then I'll go in the other direction as well. So instead of down, I'll go up 2, left 1, up 2, left 1. And that's just to make it easier for you to identify the point of intersection in case when you connect the dots, your line goes a little bit wonky. And I label my line. For the next equation, our y-intercept is -5 and our slope is 1/4. So here's the -5, and I'm going to go up 1 to the right 4, and I hit my other line right away, so I can stop applying the slope. I'll label my line, and here's the point of intersection. So therefore, point of intersection is the x value is +4 and the y value is -4. So if you did that right, very well done. If you made a mistake, see where that mistake was so that you don't make it in the future. All right, for D, our first equation looks good. Y equals -5/3x plus 1. But the second one isn't in y equals mx plus b. So we are going to have to deal with that. So for the first equation, nothing fancy. The y-intercept is 1. The slope is -5/3. So here's the y-intercept, and now I'm going to go down 5 to the right 3. Down 5 to the right 3. And then I'll go in the other direction as well. Up 5, 4, 5, left 3. And I know I did it correctly because my points are lined up. And I will label this -5/3x plus 1. Now when I look at my second equation, that's a problem. It's not in y equals mx plus b form. 2 is not the slope, 6 is not the y-intercept. So I am going to rearrange. So I need to isolate for 2y. So I'm going to bring the 2x over, and that 2x becomes negative. The 6 is fine the way it is. And I do need to isolate for y, which means I'm going to divide out that 2 to get y equals negative 1x plus 3. So my y-intercept is 3. My actual slope is negative 1 over 1. So 3 is right here, and then down 1, right 1. Down 1, right 1. Now as I'm applying the slope, I'm getting further and further from my line. So I'm going to switch directions and go up 1, left 1, up 1, left 1, up 1, left 1. And now I've reached my other line. So I'm going to connect the dots. And now, even though it might be hard to read the point of intersection, I know this is correct because I have my key points for my slope here. Therefore, the point of intersection is negative 3 for the x value and positive 6 for the y. So sometimes you do have to do that rearranging. And E is full of rearranging. So let's go ahead and try another rearranging before you try the last one on your own. So for our first equation, I'm actually going to bring the y to the right side to turn it positive. So watch what happens. The 2x and the negative 10 stay as is. The y goes to the right, it becomes positive, and I'm done. So my y-intercept is negative 10, and my slope is 2 over 1. So here's negative 10, and I'm going to go up 2 to the right 1, lots of times, to fill that grid. Now, I know it might seem silly to do it so many times, but it will potentially save you sometimes when you're trying to read off a point of intersection. And now for our next one, we're going to bring the x to the other side, and the x becomes negative. You can write the plus 0 if you want, but it's not necessary. And then I'll divide everything by 2. If you want, you can also put that invisible 1 there. So y equals negative 1/2 x, and then 0 over 2 is still 0. And some people might like to write the 0 there because that way you can see that 0 is your y-intercept and your slope is negative 1/2. So here's my 0. I'm going to go down 1 to the right 2, and that's taking me in the right direction. Down 1 to the right 2, and I hit my line. So I'll connect the dots. I'll label my lines. So x plus 2y equals 0, 2x minus y minus 10 equals 0. And you can label them with the original standard form or with the slope-intercept form. It's your call. And now for my point of intersection right here, therefore POI is 4, negative 2. So the rearranging is something you've done before, you've graphed before, but now you're just graphing two lines at the same time and reading that point of intersection. All right, pause the video here, try F on your own, then come back to check your work, and just a hint, the second equation will require some rearranging. Okay, for our first equation, the y-intercept is negative 6, and our slope is 3 over 4. So we're going to go up 3 to the right 4, up 3 to the right 4. I've run out of space, but I'll continue in the other direction. Left 3 to the left 4, just in case my point of intersection ends up being on the other side. Check to see, did you label your line? And now we go to the next one. We are going to rearrange, so the x has to move to the other side because we're trying to isolate for 2y. the x will turn negative. Maybe you want to write negative 1x. And the minus 2 stays as is because we haven't moved it. And then we can divide everything by 2. So y equals negative 1 over 2x. Subtract 1 when you do 2 divided by 2. And now your y-intercept is negative 1, and the slope is negative 1 all over 2. You can put that negative wherever you'd like. Here's our y-intercept, and now we're going to go down 1, right 2, down 1, right 2. Perfect. I have reached my point of intersection right over here. And make sure you finish this off by telling me what the point of intersection is, or else you haven't actually answered the question. You've just graphed 2 lines. So that's it. Graph 2 lines using the slope and the y-intercept, rearrange if needed, and then read off that point of intersection at the end.